Very good.
Okay, so let's get started. On to chapter 3. We're doing applications of calculus. So we've learned all of the rules required for differentiation. Now we're going to look at how can we apply those rules. So what's the utility of the usefulness of maths, right? So one of the things we will start with is what we call tangents and normals. So we've done a little bit of this last year. The only difference is it's going to be more complex because we differentiate more complex functions, right? So just have a look at our diagram there to start with. A tangent is a line that is parallel to the curve at a particular point. Parallel and touches the curve at a particular point. The normal is perpendicular, orthogonal, meets at right angles. Okay, so I'm going to go through today. There's heaps of ways of doing this, right? There's like 4 processes. I'll probably go through 3. I'll tell you which one I think is the best. You should be competent at all of them, understand all of them, and then it's just a matter of choosing which method you prefer. Okay? There are some circumstances where you are required to use one form over another. So we'll talk about them, but we need to be competent with all 3 processes. So firstly, a tangent is just the equation of a line. Okay? Y equals mx plus c. And so all we're doing then is finding the equation of a line. Alright? Now for a tangent we need 2 things. Let's say I've got the y equals x squared curve here and I want to find this tangent. Alright? We need what's called the POC. Alright? That's going to be the point of contact. And we need the slope at that point. We need the point of contact, that's where the tangent touches the curve, and we need the slope. So 2 things that we need. And so to make our argument, we're going to say what's the point of contact, what's the slope. So let's get straight into the first question. We have the function is the square root of x, and we want to find the tangent at x is 4. All right, we want to find the tangent at x is 4. So if we think of, well, the point of contact is going to be x is 4, and we need a corresponding y value. We want to go, what's the y value where this tangent touches the function? So I've got the x value. To get the y value, I'm going to take that x value and put it into the function, right? Square root of 4, positive 2. Okay, so we have the point of contact. All right, so we've got the first piece of information, we've got the POC, next we need the slope. All right, so this is what we learned in chapter 2. If we want the slope, that means we need to differentiate it, and we use the derivative function, and we put the x value into the derivative function. So firstly, I've got f of x is x to the half, so f dash of x will be half x to the minus half. Which we could express as 1 on top of 2 root x. All right, and we want to know the slope at the point of contact. When x is 4, what's f dash of 4? It's going to be 1 on top of 2 root 4. Okay, that's 1 on top of 2 times 2. That's 1 on top of 4. Okay, so we've got the point of contact. X is 4, y is 2. We've got the slope, 1/4. And so all we're doing then is we're looking for a line with these properties. Okay, we're trying to find the equation of a line with these properties. So here's the first process. Okay, the first process we're going to learn is just what I call an intuitive process. We're just finding the equation of a line with slope 1/4 that passes through this point. So we would just start by going, well, y equals 1/4 x plus c. All right, y equals mx plus c. M is the slope. We've got the slope there. The slope is 1/4. And then in order to find the value of c, in order to determine it, we're going to substitute this coordinate in. We know that on this line, when x is 4, y is 2. So let's take both of those points and put them into this equation. We're going to put the 2 where the y is. We've got the 4 where the x is, and the plus c hanging out. That's what we're trying to find. So we'll have 1/4 times 4 is 1. And so the value of C that makes this true is positive 1. I'll just make that, state that straight away. C is 1. Okay, don't stop there. You need to answer the question. The question is, what's the equation of the tangent? Well, it's going to be y equals a quarter x plus 1. Okay, so always, we need the point of contact and the slope. Once you have those 2 points, then you've basically got 4 processes you can follow. Here, just finding the equation of the line. This is my favourite because we're understanding what is an equation of a line. All right, we're not just number crunching some formula and so forth. Okay, excellent. Let's move on to the next one, which says find the equation of the normal at x equals 9 in general form. So this time we're going to use a very specific procedure. We're going to use general form. So firstly, this one says normal, the normal. And so if we have a line, and a line has a slope of A on B, then the line perpendicular to it, the one that meets it at right angles, has what we call the negative reciprocal slope. Okay, so if this is the slope of line 1, then the perpendicular line, we flip it, and we multiply it by -1. That's going to give us the slope of a perpendicular line. So, we're doing the same function, right? So, question 1, we've got square root of x. Part B, find the equation of the normal at x equals 9. So, we still need both of those things. We need the point of contact, and we need the slope. Now, we've got the x value 9. All right, the x value is 9. The y value is going to be the square root of 9 because the function is the square root of x. So square root of 9, 3. Now, if we were to find f dash of 9, so we're going to say what's the slope of the function square root of x at x is 9. All right, it's going to be, here's our slope function, right? 1 on top of 2 root x. So it's going to be 1 on top of 2 root 9, which is 1 on top of 2 times 3, which is 1 on top of 6. Okay, so the slope of the curve at that point is 1 on top of 6. But we want the perpendicular slope, okay? If we were using a tangent, yep, we're going to take 1 on 6. We're asked to find a normal. Because we're doing a normal, we need the negative reciprocal, okay? So that means we need to flip it and multiply it by -1. So this is the slope of the curve. The slope of the perpendicular line is going to be -6 on top of 1, which simplifies to -6. Okay, so we multiply it by -1. Excellent. Okay, so then let's look at how we're going to find the equation of the line in general form. Hopefully this is a skill we're reasonably competent with already. But just look in the middle of the page there, okay? And this is how we do it. We have, if slope equals 3 on 4, and it passes through the point 1, 2, then we have 3x take 4y equals, and that's how we're going to evaluate C. If slope equals -3 on 4, then we've got 3x plus 4y. Here we have slope 1 on 6, and so the ultimate question is it positive or is it negative? That's going to be the circumstance that dictates which method we use. We have positive slope, which means we're going to use the first instance, and so it's going to be, this corresponds with, in class I've written that's A on B. Maybe I'll write it like that as well. If we have A on B, then ax take by equals c. If negative A on B, ax plus by equals c. Okay, so this corresponds with this, right? We've got A corresponds with 1. So we're going to have 1x take 6y is equal to c, equal to our constant. Where have I? Oh, -6, isn't it? Yeah, very good. This is the one we're using. Thank you. Yeah, I was looking here and just going straight there. No, our slope is -6 or -6 on top of 1. Very good. So, what we're saying, which one does this, let's look there, which one does this correspond with? here, isn't it? Okay, so we can see A corresponds with the 6, B corresponds with 1. So we're going to have 6x plus 1 lot of y equals c. That set us up for the general form. Okay, 6x plus 1 lot of y equals c. And then in order to determine the value of c, all we're doing is taking the point of contact, x is 9, y is 3, and putting that in here. Alright, so we're going to put 9 where the x is, and 3 where the y is, and we'll evaluate that. 54 plus 3, 57. Okay, so then the equation of this line in general form, right, is 6x plus y equals 57. Okay, that's general form. It's general form of the equation of line because we have x and y on the same side of the equation. And this could be really easy to rearrange to get the line in y-intercept form, right? If we were to take away 6x from both sides, we would have y equals minus 6x plus 57. Now it's in y-intercept form, right? You can see very clearly y equals mx plus c. That's the y-intercept of the line. That's the slope of the line. The normal, sorry, we're talking about normal, not the tangent. So, general form, where we start with A on B, dictates which one we're going to use, generate C. So this is the equation of the line in general form, and there I've just shown you how it could be rearranged to y-intercept form. Okay, so that's part B. Alright, so we'll move on to question 2 then, and we might go through the third process. So far, let's recap the processes we've done. We did just an intuitive process, find the equation of the line. The second one we did, general form. Now there have been exam questions in the past that present lines to you in general form. So that's a skill that you do need to know. If it's a skill, like practice all 3 of them, right? But notice how in both circumstances, we still need the same information. We always need point of contact, we always need slope. All right, so always start with those things. Make a list. What's the point of contact? What's the slope? Okay, so let's look at the third process then. So, in our example here, we've got consider y equals sine x. And we want to find the equation of a normal at x is pi on 3. Okay, so we're doing a normal again, and we want to find the equation of the normal at x is pi on 3. Okay, so we still need both things, point of contact and slope. We need the point of contact and the slope. So the point of contact is going to be x is pi on 3, and the y value, when you put pi on 3 into this equation, we have sine of pi on 3. The y value, when the angle is pi on 3, root 3 on 2. Okay, then we need the slope. So in order to determine the slope, we need the slope function. We're going to differentiate. What's the derivative? When you differentiate sine x, you get cos x. And cos of pi on 3, let's communicate it. When x is pi on 3, half.
Is it meant to be negative cos because it's a normal?
Very good. Yep. So this is the slope of the tangent. Good. Yep. So over here, if we want the normal, yep. Very good. So let's call this the normal. Okay. So let's be clear. This is the slope of the curve sine x at x is pi on 3. We're asked to find the normal, which means we need the negative reciprocal, right? And so half, we're going to flip it. We'll have minus 2 on top of 1. Simplifies to minus 2. Okay, so let's use the third process then. Okay, so we've got that same information, right? We've got the point of contact, we've got the slope. That's always the same. Always the same. Always need that. Let's do the equation. In fact, Zoe, I want to keep it like that because we're going to use the formula. So this is positive half. Okay? So this is the third process. This is the formula. And so again, looking just in the middle of the page, just above, where we've got two formulas presented to you. We've got tangent, f dash of a times x take a plus f of a, and then we've got the normal, minus 1 on f dash of a times x take a plus f of a. So, in this circumstance, this is our a value. Okay, we're finding the tangent at x is a, we're finding the tangent at x is pi on 3. Okay? So let's consider the information we need for the normal. I'm going to write the equation up here, and then I'm going to make a link between these things. And then it's just a matter of smashing all that information in. So the normal has the equation, minus 1 on f dash of a, right? What's our a value? Pi on 3. Minus 1 on f dash of pi on 3 times x take pi on x take a plus f of pi on 3. Alright, so that's the equation of the normal. Alright, so we're getting that just from our sheet there. We've got a is corresponding to pi on 3. That's the coordinate where we're finding the tangent at. And so then all you're doing is we're going to take the information from here. Alright, this is the y value when x is pi on 3. This is f of pi on 3. Alright? This one is the slope when x is pi on 3. This is f dash of pi on 3. Okay, so that's that one, and that corresponds to that. And so then we're taking this information, we're going to shove that one there, f of pi on 3, that's root 3 on 2, and we're going to shove this one, half, we're going to put it there. So let's write out what we'd have. We'd have minus 1 on top of half, x take pi on 3, plus root 3 on 2. All right, now at this stage, right, you could put that in your calculator and that would be the graph of the line, okay? The only thing we can do now is simplify it a little bit. So 1 divided by a half is going to be negative 2. And I'm just going to expand this, distribute the negative 2x plus 2 pi on 3. And so that's the equation of our normal to sine x at x is pi on 3. And so we can see from here, the slope is always the coefficient of x. The slope is minus 2. The y-intercept is 2 pi on 3 plus root 3 on 2. That's going to be some decimal value, right? It's going to be an irrational number. It's going to go on forever. But that's going to be it in exact form. That's going to be something that pops up a bit as well. Finding the equation in exact form. So that's the normal. All right, so that's question 2. All right, so we'll move on to question 3 then. So we can see 3 processes there, right? So just find the equation of a line, use general forms, or you can use the formula. If you use the formula, then you don't even need to consider whether it's a normal or a tangent at that point, do you? Okay, so we have the function 2e to the x. And we're told find the equation of the tangent at x is ln b. So we're not even given a point here. We're not even given a value. We're given, it could be any number. It could be anywhere along. Find the tangent at x is ln b. So what we're going to do is just do that. We're going to find the point of contact and we're going to find the slope. Okay. So for a point of contact, we need an x value. All right, the x value is ln b, and then we need a corresponding y value. All right. So that means we need, when x is ln b, what's the function evaluate to? I'm going to make the argument over here rather than just jumping ahead to it this time. 2e to the power of ln b. All right. So just picture this part here, e to the ln b, that simplifies to b. E to the ln x simplifies to x, e to the ln b simplifies to b, so we have 2b. All right. So our x value, ln b, our y value, 2b. Okay. So I think we're pretty familiar with the process, hopefully, of finding tangents and normals. but we can see where the complexity escalates because now we've got trig functions, we've got exponentials with logarithms thrown in, whereas in the past you just did it with like quadratics and square roots, okay? So we're increasing the complexity of it. And we're finding it at some, it could be any point on the curve, right? We're finding it for the value of a variable. Okay, so that's the point of contact. Okay, next we need the slope. So we're going to differentiate this function. Now, the 2 is a number, it's just hanging out, it's a product, and when you differentiate e to the x, you get e to the x. So the function and its derivative are the same. All right? And we want the slope when x is ln b. So we want to, and I'm going to make the argument again, even though we don't need to here. 2e to the ln b. The slope is 2b as well. Right equals here. So we've got the point of contact and we've got the slope. We can find the tangent now using any procedure you like. Okay, you can use the formula, you can use general form, or we can just find the equation of a line. So let's go for my favourite, y equals mx plus c. That's the equation of a line. We've got the slope is 2b. So we're going to take that and chuck that where the m is. So we're going to have y equals 2bx. I'm going to put it in brackets just to keep it a bit neater. Y equals 2bx plus c. And we know when x is ln b, y is 2b. So let's put that in. I'll make the argument when x is ln b, y equals 2b. So to get c by itself then, so we can write it like this. Alright, so all I'm doing now, to get c by itself, I'm subtracting this, alright, or I'm moving that over to the other side. So we've got 2b, take 2b ln b, and if you want to, you could factorise the 2b. It doesn't say we need to, so either of those is a fine way of representing the y-intercept. And so then the equation of this line is y equals mx plus c. We've got y equals 2bx plus, I'll go for the second form, 2b times 1 take ln b. So the slope 2b, the y-intercept of the tangent, 2b times 1 take ln b. Okay, given the tangent at x equals ln b has a slope of 4, determine the value of b. So, here's the function, alright, here's the derivative function, and we're told at x is ln b, the slope at this x value, the slope function is equal to 4, 2b equals 4, therefore b is 2. Alright, the value of b is 2, and so we could go through and rewrite this in terms of numbers now rather than it being some variable. Alright, so we're going to leave the conjecture problems for the next lesson. This is a massive exercise, 3A. I think it goes up to like question 18 or maybe 16 or something like that. And so to start with, we're probably just focusing on the first 2 questions, which are literally just finding the equation of the tangent and normal in circumstances we're familiar with. Where the complexity increases is it gets you to do things like find where the tangent intersects the curve again. So that's going to be find the tangent and then find where it meets the curve. Definitely from now, we can use our calculator to support you. I'm going to be going through a number of skills throughout the next couple of weeks on how we can do that. But yeah, let's give exercise 3A a bit of a go. Just practicing those skills of finding